Welcome, my name is Pavel Sulinek, and in this video I would like to speak about this broken gearbox. This is Planetary Gearbox from the RR1 robot. You can see it here, and this is mostly 3D printed. Let's see the robot in more details to have the idea where the broken gearbox comes from. You can see revision 1 of the RR1 robotic arm, and this is exactly the place where the gearbox is connected to the upper arm. The upper arm is mounted directly to this output ring. So as you can see, specifically this gearbox must sustain the heaviest load because it needs to lift the entire robot. Let's see it from the back side. So this is the gearbox, and in the same orientation but taken outside. The other side of the robot, you can see big stepper motor here that powers the main joint. That's the gearbox that we are interested in, the broken one. And you can see here the encoder. The shaft of the motor goes through this rotary encoder and then goes through this part of the upper arm inside the gearbox. And in the gearbox we use special kind of adapter to connect the shaft of the motor to the sun gear of the planetary gearbox. Let's see the adapter. It is visible from this side of the gearbox. So this is the adapter. Now it is connected to the motor shaft just by pushing the opposite part of this inside. So there are no screws. Let's see how motor is connected to the gearbox. The motor uses this kind of adapter. This side is connected to the motor shaft, and this part goes directly into the gearbox, directly to the sun gear, and the sun gear, which is this black part, is connected to the motor shaft just by pressing the two parts together like this. It's very easy, but at the same time it's very tight, so there is no backlash. But the main advantage is that I do not need to use any screws here. This is important because the sun gear, which is here represented by the white part, is in very small space, and I will not be able to get here with some screws. This is not possible. It's too small space. Using the connection with the sun gear, I can mount entire motor with the adapter directly towards the gearbox, just in one step. Entire motor with this is pushed inside and attached by these 4 screws. This is quite easy. However, the connection represents also the weak part of entire construction, because I was always afraid that these small legs, especially in the case of the sun gear, can break apart from the main body of the part, because the part is printed in this way. So layers are here so the part can break along the wire, which also was my first hypothesis when I heard bad sounds from the gearbox that the legs broke. But as you can see here, when I took the part out of the robot, it did not confirm. You can see all the legs of the part are there. The sun gear is quite alright here. So the sun gear is alright, but if we turn the gearbox and look on the main ring, you can see cracks here. Hopefully it is visible, but there is crack from here to here along almost 1/3 of the actuator ring. So the damage is quite significant and maybe even worse inside. With the robot, it's quite clear that removing the gearbox from here is quite difficult, because we need to remove the upper arm from the gearbox, we need to remove the motor from the other side, and also we need to disassemble entire base to take the gearbox from the base and separate it from the robot. So it means almost entire middle section of the robot needs to be disassembled. Let's see what is inside. We will open the gearbox. All screws seems to be almost out. I'm going to use this one. And we are ready to open it. Okay, here it is. So this is the cover. This 4 bearings. And look inside what we have here. Not much damage is visible here, but we can see the problem. I can see the bolt inside the gear here is completely hidden inside. Here it is visible. So it is inside, shifted inside. So it happened that the bolt moved out of the bearing here, to move out, and it seems that this gear become completely free in the mechanism, so it is clear that it can't work because it's not pressed against the actuator ring, against the main ring here. So this gear is quite free, so it can't work, and it damaged the gearbox. You can see more cracks here on the ring. So it says that this tooth was broken. Okay. Now you can also see important design flaw here. The diameter, the inner diameter of the ring where the upper arm is connected is quite small. So there is big torque on these gears, and it was quite likely that they can break. This flaw is mitigated in the new design, except the gearbox is larger. The inner diameter of the ring, of the ring here, is much bigger than in the original design. I have to say that I expected something worse happen inside the gearbox. Except the crack on the ring and the bolt shifted outside the gear, there is no more significant damage. And this situation nicely explains the sound I heard from the gearbox. When this gear is not fixed, then it can skip the teeth on the ring, and that makes the sound. Let's open the gearbox from the other side as well. Okay, let's open it. What we will see here. Okay, the cover goes out. So this is some gear, more visible here, and the part I call cage. And we can remove the cage now. What we will see. Maybe from the other side. So these are parts of the cage, so we can remove the cage that holds planet gears together, and we can see some plastic parts here. I think this comes from the gears as they wear down, and these parts fall here. And this is the Planetary Gearbox without support, and you can see something very interesting here. So this is the first time I can see it. This part of, I think this is broken tooth visible here. So where exactly it comes from, I don't know. But this is I think broken tooth. Without disassembling the gearbox entirely, we cannot find this. So this is quite important discovery. If you look more closely on the other side, so this is the sun gear and the part where motor shaft is connected, and this planet gear does not look good. It seems that the midsection seems to be separated from the main body of the gear. It looks like being sunk inside a bit. And let me see. I think the gear moves like this. This is not normal, and it seems that this part of the gear is separated from the rest. So the gear is broken into two parts. Since that half of the gear for this ring is separated from the rest. So this is very big damage. The gear broken into two pieces. This is very important damage, and very important lesson to make the new gear. They must be stronger in the I would say vertical axis. Let's see if I can move broken part of the gear out. Yes, it moves, it works. It's out. We can see that the gear is completely broken to two parts. This is 1/4 of the gear. And broken along the print layers. You can see the infill, the perimeter layers, but completely separated. So there's quite big damage. You can also see broken tooth here. One of the tooths is separated. It is near the crack, so it's quite natural that some teeth will be separated like this. And from the other side, I think there's one more teeth, as I have shown before. One more teeth broken on this side. So the damage is much bigger than I expected. First I thought that the damage is not that big, but completely broken Planet gear is very big damage. And this is also the lesson for future gears. They must be stronger in I would say vertical axis. I have to make them much stronger in future revisions of the robot. After I found that the gearbox can't be repaired, I decided to build the new one. But at the time I already worked on revision 2 of the RR1 robot, and I already had improved gearbox for the new version of the robot. So there were two options: build the gearbox for the revision 1 in the identical way as the original gearbox, or use the new design. Because I was not able to decide by myself between the original design and the new design from revision 2, I asked my friends to vote. And the result of the vote was that overwhelming majority voted for the new design. The new design from revision 2 is this. You can see that in one of my other videos. The first difference is that it's much bigger than the original gearbox. The diameter of gearbox is wider, bigger, which has positive impact on over torque that is exerted everywhere inside. The gears inside are bigger. The outer ring, the main ring is bigger, and also the teeth of gears are slightly bigger. In the new design I use additional bearings from each side of the gearbox, which has positive impact on overall stability and rigidity of the robot. But it makes the gearbox and entire lower joint a bit wider than it is in revision 1. So I cannot use that in revision 1 with this additional bearing, because it would make the robot a bit wider, and then I would need to redesign the upper joint as well, which would be too complex redesigning and too complex repair. So I decided to use the new design, but without the additional bearings. The most important design change is the change of the material. Instead of using PETG in revision 1 and early versions of revision 2, I use PC Blend with carbon fiber for all mechanical parts inside the gearbox. So for all the gears, all the rings, and all parts that move. This is also why we can see here the gearbox from revision 2, because early design of revision 2 of the RR1 robot used PETG for entire gearbox, but then I decided to switch to PC Blend with carbon fiber, and the original gearboxes from revision 2 were removed. That's why I have it here, and the same material is used for the new gearbox in revision 1. You can see slightly different color, but the surface, this is very pleasing to look at, and even very pleasing to touch. The rigidity of the robot improved significantly. So this new gearbox is now the best part of the robot. I mentioned revision 2 of the RR1 robotic arm a few times in this video. Revision 2 is already finished, and if you are interested, please subscribe here. The next video will be on revision 2, hopefully very soon. Thank you for watching.